Sub dear viewers, in this video I'm going to show you aluminium structure design in RFEM 5. On the modeling part I used a different approach because you can see I have this a particular common space structure design. If I can show you, you can see it has a heat proof. So this is an aluminium structure. So I did not model this in RFEM. I just model it somewhere else and import it. That's what I'm just trying to say. But I will show you how. So I can just show you how you can design, and then I'm going to explain the modeling part later. You need to, after you have this structure model, and then you have the loads, you have applied the loads, the dead loads, live loads, etc., and the wind loads. You can now go to the modeling part. So to analyze and design aluminum structure, you need to go to add-on module, and then you can see there are several options for design: steel, concrete, timber, and then there's aluminum. Then because of the materials I have used, I will use aluminum ADM. Okay, so this is the general data. Can just change it. I will exclude seismic loads. And then calculate. Load combination 9 not available. So I will include all the necessary load combinations. Combination 9 is not available. So let me just exclude all these twin loads. So materials, You can go, let me first go back to modeling. I modeled this structure in StatPro. You can very simple steps model such complex structure or even more complex in StatPro. And then when you come to properties, section database, you can see steel, cold form steel, timber, and aluminum. Then you need to select aluminum. So I selected aluminum. I used the square tubes and rectangular tubes. And then you can see the properties here. So for columns, I used 7" by 7 and a thickness of about 0.2. This from here, aluminum. Then I analyzed. So for how we can model and analyze in StatPro, you need to check my other videos because I have videos on this. Then analyze after adding everything. So there's unknown material. This material, I need to assign aluminum, assign to view. Then no, don't worry about that. Then run analysis again. After this, I will export, then import. Still an unknown material. Then I exported, go to that option and then import, export, then export in this type. Because I have no analysis, I don't think I'll be able to export, but let me try. I will export maybe to desktop, then save. And then make sure you click export model. Close. And I'll go to RFEM, new. Just give it any name. Then to the positive orientation in global axis, can select downward. Standard is okay, US. Then okay. And I'll go back to file, import, start Bentley Prota STP. Make sure you select the second option. Okay. Go to desktop. Let me export again. Import, export, export. then save log and close. Open. Okay, just I'm selecting, holding control, then double click the last one. Then I will select material from here. I will select thin wall 7 by 7 by 0.2 inches or 1/8. Copy. So for material, I will select aluminum. Okay, the country, you can select US. Then aluminum, this option. Then okay. For beams, I will repeat the same. Thin wall, A is about 9.5. 4. Then paste. For material, the standard, the country, aluminum. I'm using drone tube. Thin wall 5, 4. Aluminium, drone, this one. Then I will go to the load cases. Then I will delete all these load cases. Add new ones. Then load self weight. Then I will add another live load, or is it live roof? Then add another snow, and then wind, and finally seismic. And finally seismic load. Sorry for the interruption. And then load combinations. There's these automatic combinations, result combination, then click OK. Then I can use this tool to generate loads. Area via member plane. I want to generate a live load for roof about 20 PSF, that is 20 KSF 0.20. Then I'll pick the corners. Now let me first cancel. Okay, make sure that this one here is live load. Then tool, generate loads via plane. Then I'll pick the corners from there. Again, okay. Then I'll pick another corner. I'm holding Control and press the scroll button to rotate like that. Let me escape it. Then back the origin. Okay. Then $20. Okay. Then I have snow load. Again, go to tools, load via plane. Then this one will be acting in ZP that way. Then 0.30 should be in the negative direction. Okay. Okay. Then I'll generate load. I want wind load. Tools, generate wind load, dual pitch roof. I prefer to use EN because of modeling. Okay, how you can pick the corners, you can see, you can follow this pattern A, B, C, D, E, F. So from here, basically this is A, B, C, D, E, and finally F. And click OK. And just uncheck there. Okay. Then add-on module, aluminium, ADM. Okay, general data. So for members, I'll select all. General data, materials. Just calculate. So combination 1, it was self-weight. I failed to specify. Combination 6, I can delete. Load 6, I can delete. Then OK. Then delete that row. I don't have such material. Let me add one combination with wind and start the calculation. You can see, you can do the design. Maybe the reason why we are not getting results is because the members are failing. But okay, and add another. Oh, this combination have I think seismic. So no, and let's calculate load combination 7. Anyway, this is one of the disadvantage I find with RFEM DLUBAL version 5. I don't know why it's not running some load combination, but I think the point is you can be able to design aluminum because from my observation, the design ratio is very minimum. The maximum design ratio is 0.28. And I think this is okay because at the end of the day, the most critical part is connections design. So if you go for a very small cross section with maybe a design ratio of about 0.9, the connections will fail because I think for these hollow rectangular hollow section, you're going to do there are several types of connection you can do. Maybe welding, pure weld connection between members, and I think a very small cross section with a very almost at one, a design ratio of about 0.9, I think the connections there will fail. So I think you should just go with this. Then when you're designing the connections, then you're going to check if you should reduce or increase the cross section. So this will mark the end of my video. Thank you for watching. See you in my next video.